Hi everybody, we're going to find the derivative by the limit process. This is part 3. This has cubes in it, and these are the two problems we're going to do. I think most of you all know this expansion for the binomial. Some of you all know this one, but you don't use it a lot. So this is your binomial expansion for the cube here. You all recall Pascal's triangle or the binomial theorem. So you need to know this for the derivative. So here we go. We're going to do the first one. And we can take the derivative by the limit process, which equals the limit as x, the change in x approaches 0. And if you watch the other parts, you know what I'm going to do is I'm going to just write my x. And inside the x, I'm going to put x plus delta x. Alright, and then you have to subtract the whole function. And the whole function is this. So that'd be x cubed minus 12x. And this is all over delta x. Alright, so we're going to use our binomial expansion on this part. And that's going to give you x cubed plus 3x squared, that's your a, delta x is your b, plus 3x times delta x squared, plus then delta x cubed. Then you distribute here minus 12x, minus 12 delta x, and distribute the negative, minus x cubed plus 12x. This is all over delta x. Now we're going to go ahead and simplify on this line, and everything should cancel that does not have a delta x in it. For example, this does not have a delta x, and this zeroes out with this one. Alright? And these two do not have delta x's in them, and they zero out as well. So we're left with the limit as delta x approaches 0 of 3x squared delta x plus 3x delta x squared plus delta x cubed minus 12x delta x. Now this part, I'm going to just divide each piece by delta x. And what happens is these two cancel, these two cancel, this goes into it one time, and this one goes into this twice. So we're left with the limit as delta x approaches 0 of 3x squared plus 3x delta x plus delta x squared minus 12x. So, why do I have a 12x here? Okay, so when we clean this up, we should get this right here should have been just minus 12x minus x cubed plus. This should have been just 12 delta x. Where am I? Sorry, right here. This should have been just a 12 delta x. Alright, so that would have canceled and you're just left with 12. Sorry about that. Okay, now when you plug in 0 to delta x, these two go away, and you're left with delta x approaches 0 of 3x squared minus 12, and that's your derivative. because these two zeroed out. Okay, let's do the next one. I'm going to take the derivative by the limit process. So everywhere there's an x, I'm going to put parentheses, and then I subtract my whole function. Alright, so I'm going to put x plus delta x plus delta x, and then here I'm going to put x cubed plus x squared. And this is all over delta x. Okay, clean this up. And we're going to get x cubed plus 3x squared delta x plus 3x delta x squared plus delta x cubed. And for this one, I get plus x squared plus 2x delta x plus delta x squared minus x cubed minus x squared, all over delta x. Okay, so everything without a delta x should cancel. Where's that one? And let's write this out. We get the limit as delta x approaches 0, and we're going to have 3x squared delta x plus 3x delta x squared plus delta x cubed plus 2x delta x plus delta x squared. And I'm going to go ahead and put my delta x under each piece. So these two cancel here, and we'll be left with limit as delta x approaches 0 of 3x squared. This goes into it one time, so you get 3x delta x. This goes in twice, so you get delta x squared. This goes in once, so we have the 2x plus delta x. Now, when you plug in 0 in the delta x's, that will cancel this one, and this one. So you're left with 3x squared plus 2x. Okay, the next set I'm going to do involves rationals. Thank you and have a nice day. Bye-bye.